Good morning, students. This is Shafi from Don Bosco PU College, Chitradurga. In our previous class, we learned about the problems based on finding the equation of a plane, and also we have learned that the derivation of a equation of a plane, isn't it? In this class also, we will continue the problems related to the equation of a plane. In our previous class, we learned about the equation of a plane in vector form. In this class, we are going to solve the problems related to the Cartesian form. Here we have the fourth problem. In each of the following, determine the direction cosines of the normal to the plane and distance from the plane. Here we have to find the direction cosines of the normal. In this question we have two things. We have to find the direction cosines of the normal and distance from the plane. Two things we have to find. Here it is the first problem. 2x plus 3y minus z equals to 5. It is one plane which is given in Cartesian form. It is the plane which is given in Cartesian form. In our previous class, in the note point itself, I already told you that the Cartesian form of a equation of a plane will be like this: ax plus by plus cz equals to d. In the problems, we will take the equation of a plane will be like this: ax plus by plus cz equals to d. In our derivation, we have derived that equation of a plane in Cartesian form is Lx plus My plus Nz equals to d. It is the derivation, but we have to take in the problems like this. Now, the given plane in the form of Ax plus By plus Cz equals to d, right? Here, let us identify A, B and C. Now, you just identify the things A, B, C. Here A equals to, A is nothing but x coefficient, A equals to 2, B equals to y coefficient, that is 3, C equals to z coefficient, that is minus 1. What about D? D will be 5. D equals to 5. Now, we have to find the direction ratios. We have to find the direction cosines of the normal and distance from the plane, right? Before that, you just find out the square root of, you just remember the formula how to find the direction cosines. For to find the direction cosines, we have the formula. In our previous class, I already told you in the note point itself that L equals to A by square root of A square plus B square plus C square, right? Next, M equals to B by square root of A square plus B square plus C square. N equals to C by square root of A square plus B square plus C square. So these are the direction cosines. These three things I already told you in our previous class. You just see here we have A, B, C and D. First, to find the direction cosines, we need square root of A square plus B square plus C square. For to find the direction cosines, we need square root of A square plus B square plus C square. Let us find out square root of A square plus B square plus C square. Square root of A square plus B square plus C square equals to square root of A square, that is 2 square, plus B square, that is 3 square, plus C square, that is minus 1 whole square, equals to square root of 2 square is 4 plus 3 square is 9 plus minus 1 whole square is 10. How much it will be? 14. Square root of 14. Now we have to find the direction cosines. Before that, you just identify the direction ratios. Direction ratios are what? A, B and C. A, B, C are the direction ratios. What about direction cosines? L, M, N are the direction cosines. First find out direction ratios. Direction ratios are 2, 3, minus 1. 2, 3, minus 1 are the direction ratios. Direction ratios are A, B, C. Now, let us find out direction cosines. Let us find out direction cosines. This symbol represents direction ratios. Do not confuse. This symbol represents direction ratios. This one represents direction cosines. So, direction cosines are what? L, M, and N. L, M, and N. For direction ratios, for direction cosines, what we have the formula? A by square root of a square plus b square plus c square, b by square root of a square plus b square plus c square, c by square root of a square plus b square plus c square. L equals to a divided by square root of a square plus b square plus c square, b divided by square root of a square plus b square plus c square, n that is c divided by square root of a square plus b square plus c square. Now you just substitute the values of a, b and c and also square root of a square plus b square plus c square in this direction cosines. We will get the direction cosines of the plane. Now L equals to a, what we have? 2 divided by square root of a square plus b square plus c square. What we have the value? Square root of 14. Square root of 14. Next, m equals to b. What we have? 3 divided by square root of 14. Next, n equals to c. What we have? C, minus 1. Minus 1 divided by square root of 14. Hence, these are the direction cosines of the plane 2x plus 3y minus 5 minus z equals to 5. We have to find the two things. In the starting of this problem, I already told you that we have to find the two things, that direction cosines and distance from the plane. It is the direction cosines. Now let us find out distance from the plane. That distance from the plane is nothing but perpendicular distance we have to find. Normal is nothing but a perpendicular. Normal word represent a perpendicular one. We have to find the perpendicular distance. Now perpendicular distance. What is the formula to find the perpendicular distance? We have the formula. You just see the note points what we have discussed in our previous class. You came to know the formula to find the perpendicular distance. Perpendicular formula will be d divided by square root of a square plus b square plus c square. Square root of a square plus b square plus c square. That is equals to d. What we have in the given problem? D is 5. D value is 5 divided by, now square root of a square plus b square plus c square. What we have? The value square root of 14. Hence it is the perpendicular distance. These are the direction cosines. It is the perpendicular distance. You just take a screenshot or pause the video. You just note down in your notebook. Kindly do not make any kind of mistakes in your notebook. It is the first one. It is the first question. Now let us move on to the next second question. This question will be homework for you. This question B is homework for you. X plus y plus z equals to 1. X plus y plus z equals to 1. It is the one homework. You just find out the direction cosines and the perpendicular distance. Before that, you just identify the things A, B and C. I mean what? Direction ratios. You just identify the direction ratios. Along with that, you just find out the direction cosines and the perpendicular distance. Here A equals to 1, b equals to 1, c equals to 1, and d equals to 1. That's it. Then square root of a square plus b square plus c square is what? Square root of 3. Like that, you just find out. It is the second one. Next, third one, that is c. 5y plus 8 equals to 0. 5y plus 8 equals to 0. Now, here we have the equation of a plane 5y plus 8 equals to 0. Let us find out the direction, cosines and the perpendicular distance of this plane. Solution. You just rearrange this equation of a plane like 5y equals to, you just send this plus 8 to the right, that will be minus 8. We have to represent this equation of a plane in the form of ax plus by plus cz equals to d. We have to represent the equation of a plane in the form of ax plus by plus cz equals to d. Here in the right hand side we have d. D is nothing but a distance. That distance always we represent it as a positive quantity. Here we have the negative minus 8. Here we have minus 8. We have to make it this minus 8 to plus 8. How to make it as a plus 8? By multiplying minus on both sides. By multiplying minus on both sides, then only we will get this one is plus 8. You just apply minus on both sides. Then what we will get? Minus 5y equals to plus 8. If you are getting confused, you just write it in the bracket that applying minus on both sides or multiplying minus on both sides. Right? Now, let us represent this minus 5y equals to 8 in the form of ax plus by plus cz equals to d. How to represent this plane in the form of ax plus by plus cz equals to d? Here we don't have x and z coefficients. Let us write this one like 0 into x minus 5y plus 0z equals to 8. Now it is in the form of ax plus by plus cz equals to d. Now let us identify the direction ratios. Direction ratios will be 0, minus 5, 0. Now here a equals to 0, b equals to, b is nothing but y coefficient. Y coefficient is minus 5. C equals to 0. Next, what we have to find? The square root of a square plus b square plus c square. Square root of a square plus b square plus c square equals to square root of a square is 0 plus b square is minus 5 whole square plus c square is 0. 0 square is 0 equals to square root of minus 5 whole square is 25 plus 25 equals to 5. Hence it is square root of a square plus b square plus c square. Here we have identified that a equals to 0, b equals to minus 5, c equals to 0. What about d? D is what? 8 plus 8. Okay, plus 8. Now identify the direction ratios. A, B, C. Direction ratios are A, B, C. A, B, C is what? 0, minus 5, 0. 0, minus 5 and 0. Now let us find out the direction cosines. Direction cosines are what? L equals to A divided by square root of a square plus b square plus c square. M equals to b divided by square root of a square plus b square plus c square. N equals to c divided by square root of a square plus b square plus c square. So these are the direction cosines. Now you just substitute the values of a, b and c and square root of a square plus b square plus c. In this direction cosines, we will get the required direction cosines of the plane. L equals to a what we have 0 0 divided by square root of a square plus b square plus c square, value is what, 5, 0 by 5. M equals to b is what, minus 5 divided by 5. Next n equals to c is what, 0 divided by 5. Next L equals to 0 by 5 is 0, m equals to minus 5 by 5, minus 5 by 5 is minus 1. Next n equals to 0 by 5 is 0. So these are the direction cosines. Next let us find out the direction, next let us find out the perpendicular distance. Perpendicular distance formula is what, d divided by square root of a square plus b square plus c square equals to d what we have, 8 divided by 5. These are the direction cosines, it is the perpendicular distance, hence it is the problem. You just take a screenshot or pause the video and you just note down in your notebook. Now let us move on to the next one. That question number will be d, z equals to 2. You just to find out the direction ratios and direction cosines and perpendicular distance of the plane z equals to 2. It is the one homework for you. You just do it at your home. If you want, I will give you hint for this problem. Hint will be like this. Here we have z equals to 2. Let us represent this plane in the form of ax plus by plus cz equals to 0. Let us write 0x plus 0y plus 0z equals to 2. It is not 0z, only z, plus z equals to 2. Then direction ratios will be 0, 0, plus 1. It is not a 0, plus 1. 0, 0, 1. D will be 2. Next, let us move on to the next question. Next, let us move on to the other types of questions. That question number will be fourth one. That question number will be 5. Fifth type of questions, I mean the fifth question. Find the perpendicular, find the coordinates. It is the fifth question, that find the coordinates of the foot of the perpendicular drawn from the origin to the plane. You just remember the formula, that how to find the coordinates of the foot of the perpendicular. In our previous class, I already told you that the formula related to finding the coordinates of the foot of the perpendicular. What is the formula? You just remember that formula. Foot of the formula will be L D M D N D. It is a formula. It is a formula to find the coordinates of the foot of the perpendicular is drawn from the origin to the plane. Here L is L, M, N are the direction cosines. Here L, M and N are the direction cosines. This D will be perpendicular distance. L, M, N are the direction cosines, right? This D, here we have D. D is nothing but a perpendicular distance. Perpendicular distance. Here we have a little bit difference. For to find the D, D is nothing but, it is not a D, what we found the right hand side value. Here we have to find the perpendicular distance and we have to substitute the values of L, M, N along with the perpendicular distance in this formula, that is the required coordinates of the foot of the perpendicular. Let us rearrange the given plane. 2x minus 3y plus 4z. Send this minus 6 to the right, that will be plus 6. Now you just identify the things A, B and C. You just remember for to find the direction cosines. For to find the direction cosines, we need direction ratios. So that identify the direction ratios. Here A equals to, A is x coefficient 2, B is y coefficient minus 3, C is z coefficient plus 4. Now what about D? D will be 6. D will be 6. D is nothing but a distance. It is not a perpendicular distance. D equals to 6. Do not confuse. D equals to 6 we have. Now for to find the direction cosines, we need square root of a square plus b square plus c square equals to square root of 2 square, a square is 2 square plus b square is minus 3 whole square plus c square is 4 square equals to square root of 2 square is 4 plus 9 square is, 3 is minus 3 whole square is plus 9 plus 4 square is 16. This value will be square root of 29. Now find out the direction ratios of this plane. Direction ratios are what? A, B, C are the direction ratios. Direction ratios 2, minus 3 plus 4. 2 minus 3 plus 4 are the direction ratios. Direction ratios are 2, A, B, C. That is what? 2 minus 3 plus 4 are the direction ratios. Now let us find out the direction cosines. Direction cosines are L equals to A divided by square root of a square plus b square plus c square. M equals to B divided by square root of a square plus b square plus c square. N equals to C divided by square root of a square plus b square plus c square. Now substitute the values of a, b, c with square root of a square plus b square plus c square. A, what we have? 2 divided by square root of 29. Next M equals to B minus 3 divided by square root of 29. N equals to C 4 divided by square root of 29. Hence these are the direction cosines. L, M, N we have, that is what? Direction cosines. Next we have to find the perpendicular distance. L, M, N we found L, M, N. Next we have to find the perpendicular distance. D is nothing but a perpendicular distance. It is not the value of 6. We have to find the perpendicular distance. How to find the perpendicular distance? Perpendicular distance formula we have. Perpendicular distance equals to D divided by square root of a square plus b square plus c square equals to D, what we have? 6 divided by square root of 29. Hence it is the direction cosines and it is the perpendicular distance. But what we have to find? We have to find the coordinates of the foot of the perpendicular. Therefore, foot of the perpendicular, therefore foot of the perpendicular coordinates are coordinates equals to L D M D N D. It is the formula. It is the formula to find the foot of the perpendicular coordinates L D M D and D. That is equals to L. L is what? 2 by square root of 29. L D M D and N D. You just substitute the values of L, M, N and D. L what we have? 2 by square root of 29. 2 divided by square root of 29. Next M minus 3 by square root of 29. Minus 3 divided by square root of 29. Next N 4 by square root of 29. 4 divided by square root of 29. L, M, N. Next remaining we have D, perpendicular distance. What we have? What we found? 6 by square root of 29. 6 divided by square root of 29. 6 divided by square root of 29. Kindly do not confuse. I am just replacing, I am just substituting the values of L, M, N and D. That is equals to 2 into 6 is 12 divided by square root of 29 into square root of 29 is plus 29. Next minus 3 into 6 is minus 18 divided by root 29 into root 29 is 29 only. 4 into 6 is 24 divided by root 29 into root 29 is 29. Hence it is the foot of the perpendicular coordinates. It is the procedure to find the foot of the perpendicular coordinates. Note down this question in your notebook. Next we have the next question, that B and C. So these are the questions homework for you. These are the two questions homework for you. You just do at your home. Here in this question number C, we have 3y plus 4z minus 6 equals to 0. The direction ratios will be 0, 3 plus 4. Do not confuse for the question number C. Here the direction ratios will be 0, b equals to 3 and z equals to 4. Now let us move on to the next type of questions. It is a next type of question, that find the Cartesian equation of the following planes. Find the Cartesian equation of the following planes. First question, r dot I cap plus j cap minus k cap equals to 2. Here we have to convert this vector plane into the Cartesian equation. How to find this r vector? R vector is what? R vector equals to, r vector is nothing but a position vector which is a plane passing through the point, which is a plane passing through the point P, or that point be any point on the plane. What we have taken, r vector is xi plus yj plus zk. That point will be x, y, z. How to represent that point in the form of vector form? x I cap plus y j cap plus z k cap. Now you just substitute this r vector in this equation. After that you just apply the dot product. Finally we will get the Cartesian equation. X I cap plus y j cap plus z k cap dot I cap plus j cap minus k cap equals to 2. You just apply the dot product, then we will get the Cartesian equation. x into 1, you just multiply the corresponding components of I, j and k. X into 1 is x plus y into 1 is y plus next z into minus 1 is minus z. X plus y minus z equals to 2. X plus y minus z equals to 2. Hence it is the required Cartesian equation of the plane. Next question. That question number will be B. r dot s minus 2t I cap plus 3 minus t j cap plus 2s plus t k cap equals to 15. Let us represent this vector form into the Cartesian form. I already told you that r vector will be xi cap plus yj cap plus zk cap. Xi cap plus yj cap plus zk cap dot next s minus 2t into I cap plus 3 minus t into j cap plus 2s plus t into k cap equals to 15. Now you just apply the dot product. X into s minus 2t, x into s minus 2t, next y into 3 minus t plus y into 3 minus t plus next z into 2s plus t equals to 15. Hence it is the Cartesian equation of the plane. Next, last question. This question will be homework for you. R dot 2 I cap plus 3 j cap minus 4 k cap equals to 1. It is the question homework for you. You just represent this vector form into the Cartesian form. Okay, dear students, these are the problems related to the equation of a plane in normal form. It is the class for today. In the next class, we will discuss the next derivation. That derivation is also important for 5 marks. Hence it is the class for today. In the next class, we will discuss the 5 marks important derivation. Okay, dear students, thank you.